Hi, this is Aditya Robin Singh from JDMC College Institute of Delhi. So today my lecture, which I am going to deliver, is differential equations. So these are the learning outcomes of my course to solve the exact differential equations, linear differential equation, how to solve Bernoulli differential equations, find orthogonal trajectory, and to solve rate problems. Also, we applied this method to solve the method of undetermined coefficients, variation of parameters to solve linear differential equations, and thirdly is to solve system of equations, also to solve Cauchy-Euler equations and system of linear differential equations, and to formulate and solve various types of first and second order differential equations. Next. So, firstly, what are differential equations? So, differential equation is basically a rate of change of one variable with respect to another variables. Which basically differential equation it's rate of change of some variables with respect to some another variables. There are many other types of system can be modeled by writing down an equation for a rate of change of phenomena. Like we have some examples: bandwidth utilization in TCP networks, acceleration of a car, population increase, and in chemistry labs, you can calculate the time of chemical change of some compound, locus of football. All of the above behavior can be captured by very simple differential equations. So it's a basic definition. A mathematical equation that relates a function with its derivative is called differential equation. Function usually represents a physical quantities. Derivatives represent its rate of change, and differential equation define the relation between the two. History of a differential equation. So we have first we'll study origin of differential equations, and secondly who investigated the idea of differential equation. Thirdly, the background idea behind the differential equations. Origin of differential equation. In mathematics, history of differential equation traces the development of differential equations from calculus itself independently. Investigated by English physicist Isaac Newton and German mathematical Gottfried Leibniz, and the history of the subject of differential equation is concise from synopsis of the recent article The History of Differential Equation 1670 to 1950. And this is the pictorial representation of two mathematicians so investigating the differential equations. Firstly, Sir Newton and second is Gottfried Leibniz. So now we will get the idea of what is the slope and what is the rate of change. Slope is nothing but a change in y with respect to x means how what is the changes we noted when we slide change in x. So this is we call this thing as slope. Also, we can find an average slope between 2 points, but how do we find the slope at a point? There are nothing to measure, but it's with derivative we use a small difference. Then it have trim towards zero. So we can write slope as del y over del x. Here del is equal to small change in y with respect to small change in x means when there we will change in y x there is a change in y. Notation of a differential equation. Differential equation is an equation with a function and one or more its derivative. Like in this example, we have y plus dy by dx is equal to 5x, where dy by dx is derivative term and is equal to makes this derivative as equation. So we have some example of differential equation. How when we call an equation as a differential equation. In first example, we have this is second order differential equation. Why? Because it has derivative term involved in it. In the second, also this is second order differential equation, because in this example we also have a second order derivative terms involved in this, and the derivative terms are second order and first order. But in the third one, y square plus y cap minus 1 is minus 1, sorry, minus of 2y is equal to 3. This is just a equation. In this equation, we don't have any derivative terms, so we don't call it a differential equation. And fourth one, we didn't call fourth one as differential equation because this is not an equation, and does not have an equal to sign. Formation of a differential equation. We can form a differential equation by many ways. Like we have a family of lines represented by y is equal to mx. We can find the differential equation of this family of lines. How? In derivative, what we will do, we will eliminate the arbitrary constants. Here m is an arbitrary constant. So what we will do first derivative of y with respect to x, we get the value of m in form of derivative dy by dx, and we will put the value of m in the equation y is equal to mx, and we have now we have a first order differential equation. And this is also the second example of how we make a differential equation from a family of curves. In this also, what we will do, we will remove the arbitrary terms and make it a differential equation. Third one is, in third one we don't have to do anything. We just put y in the left hand side, and now we will get a second order differential equation. What is order and degree of differential equation? Order and degree. Basically, order is the highest derivative term available in the equation, and degree is power of the highest order derivative. And point to be noted that in degree, the degree should be free from fraction and radicals. Okay, so this is the our first example. In this example, we have second order differential equation, and the degree is 1 because the power of the second order derivative is 1. In the third example, sorry, second example, the highest order derivative is 3 and its power is 1, so it is third order and first degree. Also, we have some other examples. In the first, we have degree is 2, and in the second one, degree is 1. Solving. We solve it with when we discover the function of y. There are many tricks for solving a differential equations. So, solutions of differential equation. First one is variable separation. This is the method to solve a differential equation. If we have a differential equation in the form of dy by dx equal to f of xy, we call it as separation, separable provided y of xy can be written as a product of function of x and y, like this one dy by dx equal to gx hy. So we then say we have separated the variables by taking h of y to the LHS, and the equation becomes this one, and we will solve by taking integration both sides. Second is so this we solve with the help, this is another example to solve with the help of method of separation of variable. We have dy by dx is equal to 5xy. Now what we will do, we will separate the variables of x and y and integrate them, and we will get the idea. Now second is how to solve homogeneous differential equations. Homogeneous differential equations, we will solve homogeneous differential equations by putting a variable y as a function of vx, and and we will calculate the solution in terms of v, and in the last what we will do, we will put the value of v in the solution, and we'll get us answer in form of y, like this here. Some applications of differential equation. Newton's law of cooling states that the rate of change of temperature of an object is proportional to the difference between its own temperature and ambient temperature. And these are some applications of Newton's law of cooling. Means first order differential equations से calculate कर सकते हैं. We will calculate. First, we can investigate the time of a person death. Second is in computer manufacturing, we help differential equations in making processors and also in cooling systems. Third is solar water heaters. We use differential equations, means how much time it take to heat such quantity of water. And fourth is to calculating the surface area of an object. So today is it's enough, and thank you so much. Thank you.